something is wrong with the early universe. Not wrong like a rounding error, wrong like the building shouldn't be standing, but it is. Wrong like finding a skyscraper in the middle of the Stone Age. In March 2024, astrophysicists staring at data from the most powerful telescope humanity has ever launched started noticing the same anomaly in image after image. Tiny, ancient, impossibly bright, and red. They called them little red dots. And they don't just challenge our models, they break them. The James Webb Space Telescope wasn't supposed to find anything this confusing. It was built to go back in time, not metaphorically, but literally, because light takes time to travel. Looking deeper into space means looking further into the past. Webb was designed to peer all the way back to within a few 100 million years of the Big Bang itself, to photograph the nursery of the universe. And it did that beautifully. But in almost every image of that ancient era, the same strange objects kept appearing, tiny smudges of red light everywhere, scattered across the infant cosmos like embers floating up from a fire. These weren't glitches, they weren't noise. The same objects, the same properties showing up across completely separate regions of sky. By 600 million years after the Big Bang, which sounds like a long time, but is less than 5% of the universe's current age, the cosmos was flooded with them. Then, 1.5 billion years later, they were completely gone. Just gone. That detail alone should haunt you, because it means whatever these things are, they had a beginning, a peak, and an ending. They lived and died in the universe's first chapter, and somehow we never knew they existed. When astronomers first measured them, every instrument reading came back contradicting every other reading. They were bright, blindingly so, for objects that tiny. We're talking roughly 500 light years across. Our own Milky Way is 200 times wider. Imagine squeezing a sports stadium's worth of light output into a single parking space. They were compact, so compact that even Webb, with the sharpest eyes of any telescope ever built, couldn't resolve any internal structure. Just a point of light, a single dot. And they were red, deeply, unusually red, far redder than the expansion of the universe alone could account for. Whatever was making them red, it was coming from inside. The first explanation was the obvious one: dust. Dust is a cosmic filter. It eats blue light and lets red light through. The same reason sunsets are orange instead of white. If these objects were surrounded by dense dust clouds, that would redden them. And early starburst galaxies, galaxies exploding with rapid star formation, are notoriously dusty. So the initial hypothesis was clean. Little red dots are ancient starburst galaxies, packed with hot young stars, wrapped in dust. It was elegant, testable. It almost worked. Then the math arrived. A team at the University of Texas calculated how much dust you'd actually need to produce the redness they were seeing. They worked backwards from the stellar population the light implied and came up with a number 100 times smaller than required. They were short by 2 orders of magnitude. In science, that's not a miss. That's a completely different target. So either everything we know about how stars make dust is wrong, or stars aren't the main event here at all. Meanwhile, the compactness problem was getting worse. universe. To generate that much brightness from stars alone, you'd need them packed so tightly, just a few times the Earth-Sun distance apart, that they'd be constantly colliding, merging, tearing each other apart gravitationally. The whole system would be violently unstable. It wouldn't just be unlikely, it would be physically impossible to sustain. Stars were out. So astronomers pivoted. What else in the universe produces that kind of light output from a tiny region? Black holes. Specifically, actively feeding black holes, what we call quasars, or active galactic nuclei, where gas spiraling into a black hole gets compressed to millions of degrees and blazes with the output of an entire galaxy from a region smaller than our solar system. And the evidence fits surprisingly well. Little red dots showed broad emission lines, the spectral signature of gas moving at thousands of kilometers per second around something massive and central. The compactness made sense. The brightness made sense. Even the redness made sense. A donut-shaped dust ring around the black hole, viewed edge-on, would absorb short wavelength light and let only red through. For a moment, it seemed solved. Then someone asked, where are the X-rays? Every actively feeding black hole we've ever observed, without exception, produces X-ray radiation from its accretion disk. It's like a fingerprint. You can't have one without the other. Little red dots produce zero X-rays, not a trace. And there was a second problem, almost more disturbing. The black holes in these objects appeared to be enormous, not relative to the universe, but relative to themselves. In every galaxy we've ever studied, the central black hole is roughly 0.1% of the galaxy's total mass. It's one of the most consistent relationships in all of cosmology. We think galaxies and their black holes grow together, regulating each other through feedback loops over billions of years. But in little red dots, the ratio was closer to 10%. The black hole had somehow outgrown its own galaxy by a factor of 100. It was as if the engine had arrived before the car. Two theories, two dead ends. In July 2024, a team studying the reddest, brightest, rarest objects in the sky found one so extreme it stopped their analysis cold. They called it the cliff. When they broke its light into a spectrum, they found a near vertical wall, a point at which light dropped off with a sharpness twice as steep as anything ever previously observed. That kind of cliff in a spectrum means one thing: an enormous, remarkably pure cloud of hydrogen gas surrounding the object. Not mixed, not messy, pure, dense, homogeneous, like the atmosphere of a star. But the broad emission lines underneath it said, massive black hole. So what they were looking at appeared to be simultaneously both. A black hole wrapped in a stellar atmosphere, an object that shouldn't exist in any of our current taxonomies. Not a galaxy, not a quasar, not a star. Something in between. Something new. They named it a black hole star. Here's what that means. Picture a supermassive black hole, not the naked, exposed kind we're used to imagining, but one completely enveloped in a thick sphere of hydrogen gas, dense enough to be opaque, dense enough that even X-rays can't escape it. The black hole feeds, converting matter to energy, and that energy heats the envelope, which glows. From the outside, it looks exactly like a star, enormous, luminous, red. missing X-rays? They're not missing. They're trapped, absorbed by the hydrogen shell, and re-emitted as the red optical light we actually detect. The dust shortage? Irrelevant. There's no dust. The redness comes from the opacity of the gas envelope itself. And the oversized black holes? Likely a measurement error, one caused by that same dense gas scattering light and making emission lines appear artificially broad. When researchers corrected for that effect, the black hole masses dropped by orders of magnitude, falling right back into the expected range. 3 unsolved problems. 1 object, all explained. Here's the part of this story that should genuinely disturb you. None of this was actually a surprise. In 2008, 16 years before James Webb photographed little red dots, a theoretical astrophysicist at the University of Colorado named Mitchell Bagelman published a paper describing exactly this object. He called it a quasi-star. His model: in the very early universe, a small black hole forms inside an extraordinarily dense gas cloud. Instead of dispersing, which is what usually happens, the cloud stays bound. The black hole feeds on it from the inside. The envelope glows from the energy of that feeding, not from fusion. From the outside, it looks like a single massive star. Inside, it's a growing black hole. Bagelman calculated that a black hole in this configuration could grow at extraordinary rates, thousands of solar masses in just a few million years, bypassing the speed limits we thought were fundamental. He even predicted how they'd end. Eventually, the envelope cools to around 4,000 Kelvin. Radiation pressure overwhelms gravity. The envelope disperses. The quasi-star phase ends, and a naked, fully formed, supermassive black hole remains. A supermassive black hole that appeared, seemingly from nowhere, billions of years before conventional formation models say it should be possible. Which is exactly what we see. The supermassive black holes at the centers of galaxies today have always been one of astronomy's deepest embarrassments. They're too big. They've been there too long. The conventional pathway, stellar collapse, slow accumulation over billions of years, produces black holes of maybe 10 to 100 solar masses. But we observe black holes of billions of solar masses existing less than a billion years after the Big Bang. The math has never worked. Little red dots and the black hole star model might finally be the answer. Not a slow drip feed of mass over eons, but a violent, dense, rapid inflation phase, a chrysalis, a cosmic shortcut hidden in a cloud of hydrogen that Webb just saw for the first time. A prediction that sat in a journey for 16 years, waiting for a telescope powerful enough to prove it right. Here's what I keep coming back to. These objects existed in a window. They appeared around 600 million years after the Big Bang. They peaked. And then, by 1.5 billion years in, they vanished completely, possibly because the dense gas conditions that created them simply don't exist anymore in an older, cooler, more diffuse universe. We're not watching little red dots right now. We're reading light that left them nearly 12 billion years ago. We are forensic investigators standing over ancient ashes, trying to reconstruct a fire that burned and went out before Earth even existed. And what's extraordinary is that we're succeeding, piece by piece. If black hole stars are confirmed, and the evidence is mounting, they don't just solve the mystery of little red dots. They solve the origin story of every supermassive black hole in the universe. including the one sitting at the center of our own galaxy. 4 million times the mass of the Sun. Maybe it was once a red dot too. Science doesn't always give you clean answers, but sometimes it gives you something better. A moment where the mystery gets deeper in exactly the right way, where the confusion isn't a dead end, but a door. We're standing in that doorway right now. If this kind of deep universe storytelling is why you're here, subscribe, because this channel exists for exactly this, the moments when the universe stops making sense and we figure out why.